Hello class. This video is for 2.6 transformations of functions. Again, if you are struggling with any of these concepts, make sure you email me or text me. And if you need me to do an office hour through Zoom to check your work or to do some examples together with you, let me know. All right, so 2.6 deals with transformations of functions. So in the last section, we covered functions and we looked at some basic functions, and I emphasized that you need to know those so that when we talk about taking those basic functions and doing transformations with them in here, it will be a much smoother transition if you know what the basic shape looks like and the three the standard points are. Okay, so what we're going to be doing here is we're going to be looking at the graphs or at graphing, not by making a table of points, but by looking at the equation and analyzing it. Okay. So graphing by analyzing the equation. Okay, so let's take a look at those parent functions that we looked at in the previous section. So these are our functions that we are going to focus on. So we looked at the linear function. So we looked at f of x equals x, and we saw that that was a line. We looked at x squared. That was a parabola. And we looked at x cubed. And that one is this sort of snake figure. And then we looked at two other ones, the absolute value of x, and that one has that V shape, and the square root of x, which is sort of the top half of a sideways parabola. Okay. Okay, so we're going to first take a look at transformations that deal with shifting these basic functions. Okay, so the first one, we'll take a look at our vertical shifts. So taking those parent graphs and shifting them up or down. Okay, so taking whatever function up above, f of x, and what happens is if we take any of those parent functions and we add or subtract a number to them, okay? So whether it's x squared plus a number, x cubed plus a number, x plus a number, square root x plus a number, okay, this will cause a vertical shift. If we have the plus, so if we have like x squared plus 3, then this would shift that same graph up 3 units. So here, this would go up c units. And if we subtract from those functions, like x squared minus 3, then it would go down 3 units. So subtracting c shifts the exact same graph c units. Okay. So let's take a look. So if I take each of those functions, then so we would have like x plus c, or maybe you have x squared plus c, or maybe you have x cubed plus c, or absolute value plus c, or square root of x plus c. Okay, so all of these here would take those parent graphs and shift them up c units. If we take a look at subtracting c units, or c, so if you do x minus c, or x squared minus c, x cubed minus c, absolute value minus c, square root of x minus c, all of these would take those parent graphs and shift them down c units. Okay, so let's take a look at an actual example. So if I want to graph this, f of x equals x cubed plus 2. Well, so here, since we're taking the parent function x cubed and we're adding 2 to it, then that tells me that this is going to shift the parent graph of x cubed up 2 units. Okay, so let's take a look. Let's go ahead and graph the basic graph of x cubed. And remember, it's this one. Okay, so if you recall the 3 basic points for x cubed, okay, so I'm going to go ahead and I'm going to do the x cubed graph. Looks like this. We have a point at 0, 0, 1, 1, negative 1, negative 1, right? And I'm just going to do a dash because this is not my final answer, but I am using it to help me get my final answer. Okay, so this is the parent function, x cubed. And if I want to graph this, x cubed plus 2, I need to take this exact graph and shift it 2 units upwards. So those 3 basic points, you can just take those 3 basic points that are here and shift them 2 units up. Okay, so I'm going to start with this far left point, this one over here, and I'm going to shift it 2 units up. So 1, 2. So now it's over here. Okay. I'm going to take that middle point, this one over here, and I'm going to shift it 2 units up. 1, 2. And I'm going to take that third point, the one on the far right, and I will shift that one up 2 units. 1, 2. And so my final graph, I'll do a solid line, will be this exact same graph, except it's shifted up 2 units. Okay, so that's why it's important for you to know the basic shape of these parent functions, and also those 3 standard points for each one. If you don't know the 3 standard points, it's very easy to obtain them if you just make a table, but probably a little easier if you just come up with them, if you just memorize them. Okay, so horizontal shifts. So that's when you take this x plus or minus c. Okay, so so if you do addition here, this will actually shift it left c units. It might be a little counterintuitive there, If you subtract C, then you are actually going right, C units. Okay, so let's take a look. So what would that look like if you're doing left C units? That would look something like this. F of x equals x plus C quantity cubed. Okay. And I won't write it for each one, but that's what it would look like. If you're doing right C units, then that would look like this. I'll use a different one. Let's use absolute value. So x minus C. Okay, so hopefully you notice the difference between these here and the previous way they are written over here. We can see that the constant is not inside of the absolute value. It's not inside of the radical. It's not part of the cube or the square. Okay, but down here, they are. Okay? So let's take a look at an example. Let's graph f of x equals absolute value of x minus 3. Okay, so this 3 is on the inside, and it follows this structure right over here. So this means that we are going to have the absolute value graph, and then we're going to shift it right 3 units. Okay, and if you remember, the graph of absolute value is a V shape. Okay. All right, so let's go ahead and graph that. Okay, so if you recall the 3 points for absolute value, we have one at 0, 0, 1, 1, negative 1, 1. Okay, and it's V shape. Oops, you probably want to use a dash line. Okay. So we have this V shape, and now we're going to shift it 3 units to the right. So starting with this far right point, I'm going to go ahead and shift it 3 units to the right. 1, 2, and 3. Let me use black. Okay, so this point right here has moved 3 units to the right. I'm going to take this one in the middle at 0, 0 and shift it 3 units to the right. 1, 2, 3. So it is now over here. And then this one on the left will get shifted 3 units to the right as well. 1, 2, and 3. And now this is the new location for my 3 points. And this is the new location for my V. Okay. So now let's go ahead and put these two together. let's do a graph where we do both a horizontal, vertical, and a horizontal together. Okay, so let's go ahead and graph this. Let's graph f of x equals x plus 2 quantity squared minus 1. Okay, so the parent function here is x squared, so it's going to be a parabola. So this outside number here tells me that I'm going to shift what direction? Hopefully you said down 1. And this one over here, inside, means I am going to shift what direction? Left 2. Okay. Yes, so that's the one that I said is a little counterintuitive. It's pretty much opposite direction. It's kind of like if you're trying to figure out, oh, well, what would you need to do to get back to 0? You would have to subtract 2. So you'd go 2 to the left. Okay, so let's go ahead and graph this. All right, so all right, I'm going to do the parent function in red first. Okay. So this is x squared. So we said that the parent function, the graph of x squared, is a parabola. So we have a point at 0, 0, 1, 1, negative 1, 1, and it's U-shaped, not V-shaped. Okay. And so we're going to take those 3 basic points, and we are going to shift them 2 to the left and down 1. Okay, so I will start with the one on the far left, this one over here. And I will move this point 2 to the left. So 1, 2, and then down 1. So right over here. Okay, going to take that middle point over here and shift this point 2 to the left and down 1. And doing that for the third point on the right, take it 2 to the left, 1, 2, and down 1. Okay, so these are the new locations for my 3 points. And so this is going to be the new location for my parabola. All right. Okay, so that's your horizontal and vertical shifting. That's what it looks like in an equation. So make sure you can tell the difference when you're looking at the function. Make sure you can tell which number represents an up-down and which number represents a left-right. Okay, so the up-down, that's pretty intuitive. +1 would have been up, -1 is down. It's this one inside. Remember, it's sort of the opposite. +2 is to the left, -2 is to the right. Okay, so the other sort of transformation we're going to look at are vertical stretch, or it could be a shrink, depending on the number. Or it could be a reflection. Depending on the sign. Okay, so what this is a multiplier. So we saw in the first two, the vertical and horizontal, that was addition or subtraction. So here what you're doing is you're taking some sort of a constant and you're multiplying the parent function. So maybe your parent function is absolute value of x. So if you did 3 times absolute value of x, then that would be this multiplier. And what you end up doing here is you multiply, this is very important, the original y values by this number c. Okay, so if you have all of these transformations going on, if you have a horizontal shift, a vertical shift, and a multiplier, my recommendation is that you do the multiplier first, so that you don't lose track of where your original y values are. Because if you have to multiply the original y values, but then you shift them to the left and then up, now you've lost track of where your original y values are. Okay, so if you have all three of these, the multiplier, the horizontal shifter, and the vertical shift, start off with the multiplier. Okay, so for an example of what it would look like, maybe you have something like this: f of x equals 3 times one of those parent functions. And so I'll just pick absolute value. Okay. All right, but okay, so let's actually do this problem. Okay, so this here means that I will need to multiply the original y values. Okay, not the x values, the y values. Okay, so let's go ahead and take a look at the original graph. Okay, I will do it in red. Okay, so the original graph is this V graph for absolute value. We have a point at 0, 0, 1, 1, and negative 1, 1. Okay, so I'm actually going to skip the part of doing the dashed V, just so that it doesn't get so messy. All right, so now here, well, you know what? Let me do it anyway. That way you can see how it shrinks or stretches and whatnot. Okay, so here's my original parent function. Okay, so now what happens is I need to multiply the original y values by 3. So if you can't see what these y values are, then write them down here. So we have 0, 0 over here. And then we have 1, 1 over here. And we have negative 1, 1 over here. Okay, so if I'm going to multiply the y values, the original y values, by 3, then this one here becomes 0. 0 times 3 is 0. Okay, so this is going to be my new point, which is actually the same point. This one, if I multiply the y value 1 by 3, I get 3, right? Just bring that one over. Okay, and then over here, this one over here, the negative 1 stays, and then 1 times 3, the y value times 3 is 3. Okay, you don't have to show all of this, but I noticed that in the past a lot of students can't see the y values for some reason, and have trouble doing this step in their heads. You're If you understand what we're doing here, that we're just multiplying the y values by 3, you can go ahead and do that in your head. Okay, if not, feel free to do this part. Okay, so now let's go ahead and plot those new points. So this one over here, 0, 0. This one over here, 1, 3. So let's plot that. 1, 3. Okay. And this one over here, -1, +3. So you can see here, so these are my 3 new points, and you can see how multiplying by 3 kind of stretched this V upward. Okay. So all the y values went from 0 and 1 to 0 and 3. Okay. All right, let's do another one. All right, so suppose that I have this here. F of x equals negative. Let's do negative 2x squared. Okay, so we're going to take the parent function x squared, and we are going to multiply the original y values by -2. Okay, so again, this means to multiply the original y values by -2. Okay, so let's go ahead and get our original parent graph here. Okay, let me get the red. Okay, so the original points are 0, 0, 1, 1, and -1, 1. Okay, so these are the original points for x squared, which is that parabola, which is that U shape. Okay, so we have that. And we are going to multiply the original y values. Again, 0, 0 here, 1, 1 here, -1, 1 here. Okay, so I'm going to multiply all of the original y values by -2, and that will give me my new points. This time I'm not going to write them down. I'm just going to go ahead and plot them. So 0, 0 will become 0, 0. 1, 1 will become 1, -2. So I'm going to plot 1, -2. Because I multiplied the y value, only the y value. Okay, so only the y value gets multiplied by -2. Over here, only the y value gets multiplied by -2. So I get the new point, -1, -2. So these are my 3 points. And this is my parabola. Okay. All right, so those are your vertical stretches or shrinks or reflection. So this second example here, multiplying by this negative actually reflects your graph. Okay, so it reflects this graph of x squared. It reflects it over the x-axis, And so that it's this sort of upside down U. Okay, so this is what we mean by vertical stretch, shrink, or reflection. Okay. All right, so let's go ahead and put all three of these together. All right, so let's look at this graph. Let's do f of x equals 2 times x plus 1 quantity cubed. So the parent function here is x cubed minus 1. Okay, so now we have all three things going on here. Okay, so I have this, okay, so I have this here. This is going to multiply my original y values. Okay, and this is the one that I'm going to do first. Okay, and then the other two, you can, the shifting up, down, left, right, you can do those, you know, together in one step. Okay, this here means I'm going to, it's plus 1, it's on the inside, so remember that's the one where you go in the opposite direction. So this is going to be to the left 1. And this here, subtract 1, it's on the outside, so this one is going to be down 1. And remember, x cubed graph looks like this. Okay, so let's go ahead and graph the parent function, and then we'll do all of these transformations. Okay, so let me get my red. Okay, so basic graph of x cubed. Let me get my red pen. Okay, so we have a point at 0, 0, 1, 1, negative 1, 1. Okay. And this is sort of what it looks like right now. Okay. If you want to keep it, your space clean, you don't have to do this sort of ghost graph of the parent function, since we do have quite a bit of transformations going on in this particular problem. Okay, so the first thing we want to do is multiply the original y values by 2. All right, so you know what? I'm going to go with blue this time. All right, so 0, 0 will stay at 0, 0. 1, 1 will become 1, 2, because you're only multiplying the y values, not the x value. Negative 1, 1 will become negative 1, negative 2. Okay. So this is what you have. These 3 blue points are your new points. And now we're going to take these 3 blue points and we're going to shift them left 1, down 1. And I will do that one in black. Okay, so left 1, down 1. So I'm going to start with this bottom blue point, this one here. Okay. So this bottom blue point, this one here will become, let's see, left one, down one. So left one, down one. I was supposed to be in black. Okay, so this blue point will go left one, down one over here. Okay. And this blue point in the middle, here, you know what? I'll put X's over them because I don't want them anymore. So this blue point over here will go left one, down one. Okay. And then this blue point up here will go left one, down one. Okay. So these 3 black dots are my new graph. And this is what it would look like. You see how it got a little more stretched compared to the original red one. Okay, so that's that multiplier 2. Okay, let's do one more just to make sure. Let's do this. F of x equals negative absolute value x minus 2 plus 1. Okay, so you might want to pause the video right now and see if you can do this on your own, and then go ahead and once you're done, go ahead and play it to see if you get the same answer as I do. Okay. All right, so this is the absolute value graph. That's the V. This number out here tells me I need to multiply my original Y values. This one over here tells me I'm going to shift the opposite direction that you're thinking. So this will shift right 2. And this one here will shift up 1. Okay, and again, the graph is a V. So let's go ahead and graph the original parent function. Okay, so let me get my red pen back. Okay, so the original parent function has points at 0, 0, 1, 1, negative 1, 1. Okay, so we have these 3 points. We always start off here with our multiplier. Okay, we start there. Okay, so multiply all the original Y values by negative 1. Okay, so let me go blue. So this one will stay at 0, 0. 1, 1 will become 1, negative 1. And negative 1, 1 will move down here. Okay. And now I will take these 3 points, these 3 blue points, and I will shift them right 2 and up 1. So, and that will be my final graph. So starting with the one on the far right, this one over here will go right 2, 1, 2, and up 1. Okay. The one here in the middle will go right 2 and up 1. So right 2 and up 1. right over here. And this one on the far left will go right to 1, 2, and up 1. Okay, so these are my three final points, these three black ones here. So I will go ahead and draw my V, which is now reflected because we multiplied by a negative number. Okay. All right. So if you have any questions, make sure you message me. This is the section where you do begin to have homework online on WebAssign. So make sure that you do have your account up and running. Do not fall behind. This homework is due in 1 week. You only have a 1 week window to complete this. So hurry up, pay for your account, and start working on the homework because we will be getting another one as well. Okay. All right. Enjoy your day.